And it appeared to be doing this in a period of order of 8 hours. Now that tells us two things about 1993 SC. It tells us A, that it's not spherical. You need to be elongated to get a light variation. And also it tells us the rotation period is either about 8 hours or possibly about 16 hours if you think we're seeing it twice.
Full of interest. Ian, how many of these remote objects do you think there are?
Probably millions. But we only know of 18. 17 if you read the literature up to 2 days ago. But last November, Alan, Donald and myself had a night on La Palma, only one night unfortunately, and we thought we had discovered another one, but one night is not enough to confirm the existence. Fortunately, we had another night 2 nights ago, and I'm glad to say the object was recovered 2 nights ago and has now been given a temporary designation 1994 VK8. So there are now 18 of them.
Many congratulations, but I gather there are two definite classes of these remote objects. Those whose paths keep them well out beyond Pluto, and those whose paths are very similar to Pluto's. Is that fair?
Yes, I think we have examples of both of them. 1992 QB1 and this object we have just discovered now. Those are very clearly outside the orbit of Pluto, moving on nearly circular orbits. On the other hand, 1993 SC and a few of the others would appear to be on this Pluto-like orbit, that is, they're on an eccentric orbit, probably in resonance with Neptune. Now that's nothing to do with the other difference which we appear to see on the screen, which is that some object appeared to be at 3 o'clock and another collection at around sort of 9 o'clock. Now that is nothing but really observational selection. We happen to get telescope time around September and around March.
What about sizes?
Sizes, again, for the 18 we've got, vary from something of the order, say, of 60 miles. 60 miles is, roughly speaking, the area within the circle of the M25, to something considered bigger, of the order, say, of 200 miles, which takes you, roughly speaking, from London to Liverpool.
Now, there are other strange things too, and I'm thinking, of course, of Chiron, discovered way back in 1977. There's a picture of Chiron, that blob in the middle, and you can see that kind of fuzz over to the upper left. That appears to be a kind of a temporary atmosphere, so we don't really know quite what Chiron is. Certainly, it goes around the Sun in a period of 50 years and spends most of its time between the orbits of Saturn and Uranus, so that again is rather different. But certainly, we are now finding objects in the remote part of the solar system. Why do you think that they weren't discovered before, Ewan?
I think there are two reasons. One of them being that they're very faint. We've got to remember that things like 1993 SC, which is one of the brighter ones, is 22.5 magnitudes. Others are 23, even approaching 24. Now that is actually fainter than the general background sky. And you can only therefore detect them if you have some mechanism almost of removing the background sky. And that really only became feasible when CCDs became available, and in particular when they became large enough so they can look at a significant area of the sky. So I think there's a technical problem that we couldn't do it was one reason. The other one was that until recently, nobody really probably looked.
Why not?
I think because people for a long time were happy with the view they had of the solar system, with comets coming from the Oort cloud through perturbations and then falling into the inner solar system. Problems became apparent when you start looking at the distribution of the inclinations of the long period comets. It appears to be pretty random with a peak at 90 degrees. They can come from any direction, in other words. Whereas if we look at the short period comets, they're very, very different. They all seem to lie very, very close to the ecliptic in the same plane as the planets. People had thought that the reason for this may well be the gravitational field of Jupiter and Saturn, maybe perturbations, pulling them down into the plane. But recent detailed models show that this really is not possible. You can't pull these random orbits all into the inclination, and it needs some other explanation.
Well, what do you think the answer is?
I think a simple answer is to say there is a belt out there somewhere of comets of these objects, and occasionally these then move into the inner solar system. Now this belt one would traditionally perhaps call the Kuiper belt.
Yes, because it was first suggested, I think, way back in 1950 by the Dutch astronomer Gerard Kuiper, and he believed that this thing was there. But only recently have we actually found Kuiper belt objects.
That's right. We've got to remember, of course, that Kuiper was not predicting a belt for the sake of a belt. He came upon it through thinking about the origin of the solar system. He thought that the solar system would actually build up through the accumulation of planetesimals. The idea is very simple. There's a swarm of small bodies around the proto-sun. Those near the sun move faster than those on the outside and catch them up. They collide and build into bigger and bigger objects. Those near the sun build up very quickly. Those further out take a lot longer to catch up and build up. And at some point you run out of time. And we suspect that you ran out of time just beyond Neptune, and therefore there's only a swarm of protoplanets beyond Neptune.
Well, it seems that very reasonable. And I just wonder, what is a Kuiper belt object going to be like? Well, there's an impressionable one. Whether it's accurate, of course, we can't tell. But it could be icy, it could be cratered, it might be a non-spherical in shape. And if you could go there, it would be a very, very desolate scene. Bitterly cold, of course, and even the sun appearing is only a brilliant point in the blackness of the sky. And I wonder whether anyone actually will see that. And there's another point too, Ian. We've now got these Kuiper belt objects, right. But there have been suggestions for many years there might be another large planet out there, way beyond Neptune and Pluto. We've been calling it Planet X and having a look for it. What do you think about that?
I think it's a fascinating idea, but the existence of Kuiper belts, I think, tends to mitigate against it. It says that Kuiper was right, that time to build up big planets has run out after Neptune. We can't build up big things out there. And that would suggest, therefore, we are now seeing, if you like, a planet which didn't make it in the Kuiper belt rather than Planet X.
I imagine that now these first objects have been discovered, people like you are going to go on making very energetic searches for more Kuiper belt objects.
Well, I think we need two things. We need to find lots more so we get some idea of the sizes and the size distribution. We also need to make sure we understand what the orbits of those we've already found are like. Like I said at the beginning, out of the 18 so far discovered, only 6 have anything like real orbits. The rest are just guesses at circular orbits. So we'd more time to look at all those we know, as well as finding new ones.
Once you've found these things, is it difficult to keep track of them?
I think if we get telescope time about once a year, unless the orbits are absolutely crazy, they should be within a reasonable CCD frame of where any predictions produce them. Therefore, we should be able to recover them after a year interval. And so if you get that time, it's all right. Give a gap of 3 or 4 years and it gets a very different problem.
Well, certainly it's an entirely new study and a fascinating one. Johan, thank you very much.
Thank you for asking me, pleasure.
Now, don't forget, if you want the latest information, then you can ring up our Sky at Night information line, 0891 800 330, or you can dial up CFAX, page 615. And when I come back next month, I'm going to be joined by Dr. Peter Cattermole, and we're going to talk about the planet Mars, now nearly at opposition, a bright red star-like object shining in the evening sky among the stars of Leo. So, until next month, good night.